So we've talked about limits, so the next logical step is continuity. Well, let's look at this definition. A function, f of xy, is continuous at ab if the limit as xy approaches ab of f of xy is equal to f of ab. We say f is continuous on D if it is continuous at every point in D, which is nice to say. If we know a function is continuous, we can find the limit. So facts for checking continuity. Polynomials are continuous. Sums of continuous functions are continuous. Products of continuous functions are continuous. Quotients of continuous functions are continuous when the denominator is not equal to 0. So let's use these facts to be able to figure out something about our function better. And the last thing is the composition of continuous functions is continuous. So we can ask ourselves, does the limit of xy approaching 0, 0 of f of xy, which is 4 minus xy all over x squared plus 3y squared plus 1, does this limit exist? Well, let's think about it. 4 minus xy. X is a polynomial that's continuous because it's a polynomial. Y is a polynomial that's continuous. The multiplication of continuous functions is continuous, so xy is continuous. So 4 minus xy is continuous. X squared is continuous because it's a polynomial. 3y squared is continuous because it's a polynomial. 1 is a polynomial, I guess, which is continuous. And the sum of them is continuous because the sum of continuous functions is continuous. So the top and the bottom are both continuous. So the only thing left to check to determine if this is a continuous function is to determine if it's equal to 0. Well, at 0, 0, the bottom is going to be equal to 1. So we're good. We are not dividing by 0 in this case. We could figure out where we're dividing by 0. Just set x squared plus 3y squared plus 1 equal to 0. And in fact, you'll see that that is never going to be 0 because x squared and y squared are always a positive, and you have that plus 1 there. So you always have a positive number on the bottom. So therefore, this function is continuous. By definition, the limit of continuous functions exists. So therefore, this limit does exist. And in fact, if you wanted to calculate it, it is just 4. Let's determine where g of xy equaling the natural log of x squared plus y squared minus 4 minus square root of y is continuous. Well, for domain purposes, we know that y already needs to be greater than 0 or equal to 0 because we can't take the square root of a negative number. Now we know x squared plus y squared minus 4, that has to be greater than 0. In other words, x squared plus y squared has to be greater than 4. So x squared plus y squared, if we create a little graph, x squared plus y squared equaling 4 is just the circle of radius 2. And for this condition, the domain has to be greater than this, but y has to be greater than or equal to 0. So in fact, this will be the domain of the function. Everything that is outside this circle, including this axis, and greater than there. And that's going to be the domain of our function. And in fact, that defines whether or not where this is continuous, because natural log is continuous as long as we have a greater than 0 here. And then square root of y is also continuous as long as we are greater than or equal to 0. And we have just some subtraction, which that's all we care about because the sum of continuous functions is continuous. So we have in this domain here, that is where we have a continuous function.